Deep in the heart of our own galaxy, hidden from the prying eyes of optical telescopes, lies one of the most extreme and enigmatic environments in the entire Milky Way. This region is a swirling vortex of energy and matter. It is dominated by the immense gravitational pull of a supermassive black hole. Stellar densities here are 1,000,000 times greater than in our neighborhood, and the very fabric of space-time is warped. For centuries, the galactic core remained a mystery, shrouded behind curtains of interstellar dust and gas. Those dark clouds absorb visible light, creating a cosmic veil astronomers have long sought to pierce. Imagine a journey of 26,000 light-years towards Sagittarius. Near the luminous central bulge, the star fields crowd together. A glittering ocean of countless suns fills the view. Then you hit the Great Rift, dark dust lanes that slice the Milky Way in two. These are colossal clouds of cold gas and microscopic dust particles, dense enough to block light from billions of stars. Within this obscured territory, just 390 light-years from Sagittarius A, our destination lies. This is a realm of scale and violence, where creation and destruction play out on a galactic stage. Intense gravity from the black hole and a dense star cluster make it hostile, yet fertile. Gas and dust are not calm. They're churned by powerful magnetic fields, buffeted by shock waves from ancient supernovae, and blasted by the fierce light of thousands of massive young stars. It's a cosmic tempest that pushes star formation to the limits. Understanding this turbulent heart is key to the Milky Way's life cycle. Here we find the single largest and most productive star-forming factory in our galaxy. A giant molecular cloud, a colossal reservoir for making stars and planets. It dwarfs familiar nurseries like the Orion Nebula. This behemoth reveals how stars form under extreme conditions, a local lab for processes common in the early universe. Its name is Sagittarius B2, a true giant of the cosmos. Deep in the heart of our galaxy, hidden behind dense curtains of interstellar dust, lies one of the most extreme environments in the Milky Way. A giant molecular cloud so massive and rich in raw material that it has earned a place as the single largest star-forming factory in our galaxy. This is Sagittarius B2, a colossal cloud of gas and dust orbiting close to the Milky Way's central supermassive black hole, stretching over hundreds of light-years and containing enough material to form tens of millions of suns. It is a place where the galaxy's future generations of stars are born. In this documentary, we'll explore the latest discoveries about Sagittarius B2, what it is, why it matters, and how the James Webb Space Telescope has given us the clearest look yet into this cosmic nursery. Sagittarius B2, often called CGR B2, is a giant molecular cloud complex located only about 390 light-years from the very center of the Milky Way. Located in the direction of the constellation Sagittarius, this region is so packed with dense molecular material that it's considered the largest known reservoir of star-forming gas in our galaxy. The environment here is extreme. Unlike smaller star-forming regions like the Orion Nebula or the Eagle Nebula, CGR B2 is dominated by enormous clumps of gas, each capable of forming thousands of massive stars. Its density and richness in molecules make it one of the brightest radio wave sources in the galaxy. Astronomers often call it a molecular treasure chest, because over 60 different types of molecules have been detected here, from water and carbon monoxide to more complex organic compounds. To understand why Sagittarius B2 is so special, we first need to understand molecular clouds themselves. These are cold, dense regions of the interstellar medium. In these dark clouds, temperatures can be as low as just 10 to 20 Kelvin above absolute zero. Gravity slowly pulls matter together, forming clumps. When the clumps reach a critical mass, they collapse inward, igniting nuclear fusion, and a star is born. All stars, including our Sun, were born in molecular clouds. The Orion Nebula is a well-known nearby example, but Sagittarius B2 is thousands of times more massive, capable of producing entire clusters and stellar nurseries at once. Unlike other star-forming regions we study, Sagittarius B2 sits extremely close to the galactic center, the home of the supermassive black hole Sagittarius A. This means stars here are forged in one of the most energetic regions of the Milky Way, under conditions of extreme pressure, turbulence, and strong magnetic fields. Studying Sagittarius B2 doesn't just tell us about this one region, it gives us insight into how stars can form in the most difficult environments similar to what we see in distant starburst galaxies. For decades, Sagittarius B2 was shrouded from view. Dense dust made it invisible in visible light. Only radio telescopes and sub-millimeter observatories like ALMA could begin to peek inside. But recently the James Webb Space Telescope has changed everything. With its powerful infrared vision, Webb can cut through the obscuring clouds and expose the heart of Sagittarius B2 in stunning detail. NASA's Webb observations revealed cosmic caverns and intricate networks of gas and dust filaments, structures shaped by powerful stellar winds and radiation from young, massive stars. For the first time, astronomers have identified deeply embedded protostars, glowing jets, and outflows within SCAR B2, providing a window into the very moment of stellar birth. Inside Sagittarius B2, thousands of stars are being born right now. Many are massive O and B-type stars which live short, intense lives and end in spectacular supernova explosions. Protostars detected by Webb, outflows shaping the cloud, massive clusters forming simultaneously. Unlike smaller clouds, SCAR B2's star formation happens in bulk, creating stellar clusters instead of individual stars. Some of these clusters resemble mini-galaxies, with hundreds of stars forming together bound by gravity. What makes Sagittarius B2 even more fascinating is its chemistry. Astronomers have detected more complex organic molecules here than almost anywhere else in the galaxy. These include alcohols, formaldehyde, and molecules that are precursors to amino acids. This richness in chemistry has made SCAR B2 a prime location for studying the potential building blocks of life. While it is not a place for life itself, it's too hostile. Its molecular diversity is crucial for understanding how organic chemistry spreads through the galaxy. Studying Sagittarius B2 can also help us understand how stars may have formed in the early universe. Galaxies billions of light-years away, often studied by Webb, also show dense, turbulent starburst regions. But because those galaxies are so distant, they are harder to study in detail. Sagittarius B2, right here in our galaxy, acts as a close-up laboratory for the same processes. Sagittarius B2 is the local example of extreme starburst conditions. By connecting Webb's galactic center results with extragalactic observations, scientists are piecing together a universal picture of how stars form across space and time. What does the future hold for this mighty cloud? Over millions of years, Sagittarius B2 will use its fuel to form stars and clusters. But massive stars don't live long. Their winds and supernovae will blow away much of the cloud's material, eventually dispersing it and leaving only clusters of stars behind. This cycle of birth and destruction is what drives the life of galaxies. Sagittarius B2 is one of the most powerful engines powering the evolution of the Milky Way's inner regions. Sagittarius B2 is the beating heart of starbirth near the center of our galaxy, a place where matter transforms into light, where stellar giants are forged under extreme conditions. Thanks to the James Webb Space Telescope, we are now able to see this nursery in unprecedented detail, finding not just stars in the making, but the building blocks of chemistry that could one day seed new worlds. Exploring Sagittarius B2 deepens our understanding of where the stars of tomorrow are born, and reminds us that even in the densest cosmic shadows, the light of creation is always at work.